Hello, curious minds of the universe. Have you ever stopped for a moment, looking at the twinkling stars, or perhaps just boiling water and thought, wait, how does that really work? Because, let's admit it, our universe is a decidedly bizarre place. We think we understand everything, have put labels on every phenomenon, laws etched in stone by science. But the truth is, the more we dig, the more we discover things that make us scratch our heads, stuff that seems downright impossible. Today, we're going to dive headfirst into the strangest corners of reality, into those phenomena that seem to have swallowed the laws of physics and spat them back out in a, let's say, creative form. We're going to dissect 10 of the wildest things discovered by humanity, things that will make you doubt everything you thought you knew. Get ready, because your perception of reality is about to get a serious refresh. Here we go, for a journey through the absurd and the marvelous. Let's go. Number 10. The sun makes things hotter than itself, the corona effect. We begin our exploration with our own sun. Ah, the sun, our star, our source of life, our cosmic puzzle. We think we know it, right? It's a giant ball of fire, incredibly hot. Easy, except not quite. There's this fascinating, a bit baffling thing called the corona effect. And let me tell you, this thing defies our intuition. You see, the sun's corona is the outer layer. It's made of plasma, a superheated, ionized gas. Logically, it should be less hot than the sun's surface, where nuclear reactions occur. But, surprise, the corona is hotter than the sun itself. Yes, you heard that right. We're talking millions of degrees Celsius for the corona, while the surface is only a few thousand degrees. It's like approaching a campfire and finding yourself in an air-conditioned room on full blast. It's completely counterintuitive, isn't it? Scientists have been on this for ages, and frankly, they don't have a definitive answer yet. There are theories, of course. There's talk of magnetic waves propagating from inside the sun, transporting energy to the corona. Or perhaps there's a strange ratio between particle mass and their speed that causes this overheating. But for now, it's a bit like looking for a needle in a cosmic haystack. It's the sun, literally playing with us with its own heat. Pretty cool, right? And that's just number 10 on our list. We still have a lot of strange things to discover. Number 9. Military invisibility cloaks, magic within reach. If you grew up with Harry Potter, the idea of an invisibility cloak must resonate with you. The object that allows Harry to sneak around everywhere, escape teachers, and get into mischief discreetly. Well, what was once pure fantasy is becoming a reality. And not just any reality. The military is very interested. A company called Hyper Stealth Biotechnology has developed a kind of revolutionary fabric. Imagine a material that doesn't make you invisible by magic, but by incredibly clever science. This fabric has the ability to bend light around whoever wears it. In other words, light passes through the fabric as if nothing were there. For us, looking, there's nothing to see. It's as if the object or person doesn't exist. The result? Perfect invisibility. Think of the applications. Infiltration missions would become child's play. Rescue operations could be carried out undetected. Traditional camouflage could be revolutionized. It's fascinating to see how concepts that seemed reserved for science fiction are starting to anchor themselves in our reality. It's a sign that technology is advancing at breakneck speed. And who knows what the future holds. Gadgets worthy of the biggest sci-fi movies, literally within reach. It's quite dizzying. Number 8. Temperatures below. Absolute zero. Colder than cold. We're stepping up the strangeness with number 8. Temperatures below absolute zero. I know. For most of us, we use Celsius or Fahrenheit. Absolute zero is the coldest possible point, the moment when particles are completely still. It's the zero level of heat. You can't go below it. It's like a floor, except its temperature. And yet, scientists have managed to create substances that are colder than this absolute zero. How is that possible? Well, you have to delve into very complex mathematics and concepts like Boltzmann distribution, which I'll spare you here. The general idea is that they've managed to manipulate gases in a way that gives them, let's say, unnatural properties. These gases behave almost as if matter had negative properties. It takes a lot of energy to keep these gases at such low temperatures we can't even conventionally conceive of. Scientists are putting a lot of effort into this, not so much for immediate application, but to push the boundaries of what we think we know. That's the beauty of science, exploring frontiers, even when they seem to defy all logic. It's proof that even the most fundamental concepts can be reinvented. Number 7. The Higgs mass hierarchy problem. When gravity takes a nap. We move on to number 7, and here we're getting into the nitty-gritty of particle physics. If you're familiar with the field, you've surely heard of the Higgs boson. Before its discovery, we didn't understand much about how things acquire mass, and by extension, how gravity works at a fundamental level. The Higgs boson is sort of the missing piece of the puzzle that gives mass to everything that exists in the universe. And mass is what connects us to gravity, the force that holds galaxies together and keeps us from floating off into space. Now here's the weird part. Gravity, as we know it, works very well on a large scale. We understand it. But when we descend to the microscopic scale, everything gets complicated. If you look at very small masses, gravity seems to almost disappear. It's as if gravity decided to take a nap when no one is looking. This is what's called the Higgs mass hierarchy problem. The forces in the universe should be consistent, regardless of scale. They should have the same impact on small things as on large ones. But with gravity, that's not the case. This little Higgs boson, by giving mass to particles, creates a fundamental imbalance that leaves gravity in a state of total confusion at the quantum scale. It's as if the rules of the game change completely when you look closely. Number 6, the particle that is both matter and antimatter, the Majorana Fermion enigma. We're going to talk about matter and antimatter. You know, antimatter is the opposite of matter. An electron has a negative charge. Its antiparticle, the positron, has a positive charge. And when matter and antimatter meet, they annihilate each other in an explosion of pure energy. It's sort of the ultimate catastrophic scenario. The thing is, when the universe formed, it should have created as much matter as antimatter. Logically, everything should have annihilated instantly, leaving us in nothingness. But here we are, sitting, watching this video, made of matter. So why? What made matter take over? One of the keys to understanding this might lie in a theoretical particle called the Majorana fermion. The crazy thing about this fermion is that it could be its own antiparticle. Yes, a particle that would be both matter and antimatter. If such fermions exist and annihilate, it could explain why there's more matter than antimatter in the universe. The problem? Proving their existence is incredibly difficult. It's like trying to find a needle that is also its own thread in a gigantic spinning mill. Fortunately, scientists have managed to create something similar in the lab, quantum states that behave like Majorana fermions. These particles could play a crucial role in the future of quantum computing. It's one of the great mysteries of the universe, and it's through discoveries like these that we advance. Let's move on to today's subscriber's topic. Now, look closely at this image. We see a man under a radiant sun holding a yellow bus on his shoulders as if it were nothing. He's surrounded by people in what appears to be a lively street. The scene is surreal, almost dreamlike. We know it's the kind of image that circulates on the internet, the ones that make us ask 1,000 questions. Is it a fake, an optical illusion, or is it an absolutely extraordinary demonstration of strength? Something that defies our very understanding of human physics and physiology. There's a story circulating, a possible explanation, but it remains difficult to verify. According to some accounts, this image comes from a public event or a performance in an African country, where a man, perhaps an athlete or an artist, achieved this incredibly heavy feat. It's said to be a test of strength, a local tradition, or even a form of spectacle aimed at impressing. But without a reliable source, it remains a mysterious anecdote, an image that defies our common sense and leaves us perplexed. It's this kind of visual mystery that makes us doubt what we see and fuels our desire to understand the world. Number 5. Floating aluminum foil. Gravity at its most amusing. We're going to play with gravity in a surprising way. Have you ever seen those little science demonstrations where a piece of aluminum foil floats in a tank? It looks like magic, doesn't it? It seems like gravity has decided to take a break. But don't worry, it's not magic. It's well-oiled science. The secret lies in the gas contained in the tank. It's not ordinary air. It's sulfur hexafluoride. This gas is much denser than the air we breathe. Imagine filling a balloon with helium, which is lighter than air, and trying to make it sink in water. Sulfur hexafluoride is so dense that it behaves like a liquid compared to air. So when you place this aluminum foil, which is much less dense than sulfur hexafluoride, into this gas, it floats. It's the same principle as wood floating on water. It's simple, elegant, and very visual. And this gas, sulfur hexafluoride, also has another amusing property. If you inhale it, it makes your voice incredibly deep, as if you were a demon. It's the sworn enemy of helium, which makes your voice high-pitched. So, not only can we make objects float, but we can also transform our voice into a macabre melody. It's the kind of thing that always gets the crowd applauding. Number 4. Memory metal, the science that remembers its shape. We're touching upon a material that seems straight out of a science fiction film. This metal you see is not a manipulated image or a fast-forwarded video. It's a metal called nitinol, an alloy of nickel and titanium. And it has an absolutely fascinating property called shape memory. This metal was initially developed by the US Navy, and it's capable of remembering its original shape. How does it work? Well, you can shape it at a certain temperature. Then you cool it down. At that point, it becomes malleable. You can twist it, bend it in all directions, like modeling clay. But the most incredible thing happens when you reheat it. As soon as heat is applied, the metal returns to its initial shape, as if it remembered its past. It's like having an object with an intrinsic memory. Stents, those little tubes used to keep arteries open during heart surgery, are often made of nitinol. They are shaped into their final form at body temperature, then inserted into the artery. Once in place, a slight increase in temperature is enough for them to open up and take their intended shape. It's an incredible medical advancement, but nitinol's potential is just beginning to be explored. We're talking about clips for cigarettes, toys, and perhaps one day, much more. It's science showing us that even inanimate materials can have a form of memory. Number 3, Heron's Fountain, an ancient hydraulic trick still astonishing. We're approaching the podium with number 3. We're going to talk about Heron's Fountain. Imagine an object created almost 2,000 years ago, around the 1st century AD, by Heron of Alexandria, a brilliant physicist of the time. He studied air and steam, and even described the principle of the steam engine before anyone else. But this fountain is mainly used in physics classes today to demonstrate basic principles. Basically, the fountain appears to be a perpetual motion machine. You build it with 3 containers and 3 tubes, often using plastic bottles and straws to keep it economical. The water seems to cascade upwards, defying gravity, with no external energy input. It gives the impression of a magic trick, doesn't it? But of course, a perpetual motion machine is impossible according to the laws of physics. Heron's Fountain, however, works for a certain time thanks to a clever combination of gravity and air pressure. Water descends into one reservoir, pushing air into another reservoir where it's contained, creating pressure that in turn pushes water upwards. It's a cycle that eventually stops when there's no more water or potential energy. But in the meantime, it offers a stunning visual demonstration of the principles of hydraulics and pneumatics. It's a perfect example of how understanding physical laws can create effects that seem to defy nature itself. Number 2. Inverted waterfalls. When water defies gravity. Waterfalls are among nature's most majestic spectacles. Water cascading powerfully downwards. But now, imagine the opposite. Water rising, climbing uphill, defying all logic of gravity. These are inverted waterfalls. It seems impossible, doesn't it? Of course, there are many manipulated videos online, but real inverted waterfalls do exist. And their explanation is surprisingly simple. Once you think about it, in a normal waterfall, gravity wins. Water is pulled towards the ground. But in the case of an inverted waterfall, the wind blowing at the top is so strong that it's equal to, or even greater than, the force of gravity. It pushes the water upwards, projecting it against the rock, making it rise instead of fall. It's fascinating to see how such a spectacular phenomenon, which seems to defy physics, can have such a simple explanation. It reminds us that in nature, there are always subtle balances, forces at play whose interaction can create unexpected wonders. It's beautiful, it's mysterious, and it shows us that even the most obvious things can behave in surprising ways. Number 1. Lahana Noon, the mystery of the disappearing shadows. We arrive at the summit with number 1, and this happens when the sun is exactly at its zenith. There's a phenomenon called Lahaina Noon. It's a phenomenon that occurs in very specific locations on the planet, and the most famous is in Hawaii, hence the name. It's that precise moment of the year and day when the sun is directly overhead, precisely vertical. And then something strange happens. Objects no longer have shadows. Yes, zero shadow. Shadows are what happen when light is blocked or deflected by an object. But when the sun is directly overhead, the light comes from above, and there's no angle to create a projected shadow on the ground. For us, who are used to seeing shadows everywhere, it's a disorienting experience. Our brain is used to ignoring shadows when they're not necessary, but when they suddenly disappear, it forces us to pay attention. It can be a bit unsettling, even downright scary for some. It's interesting to think that this phenomenon, so peculiar and rare, can only be experienced in a few specific places in the world. Most people will never see it in their lifetime. It's a unique spectacle, a curiosity of nature that reminds us that even the most mundane things like shadows can have extraordinary moments of absence. There you have it. We've reached the end of this journey through some of the strangest wonders our universe has to offer. From the sun superheating itself, to invisibility no longer being science fiction, to temperatures colder than absolute cold, particles that are everything and their opposite, gravity playing hide and seek, and even water flowing towards the sky. And that intriguing image of a man lifting a bus, which leaves us with so many unanswered questions. So, which of these wonders left you most speechless? Do you think science will one day explain all these oddities? Feel free to share your thoughts in the comments below. And if you've encountered things that seem to defy the laws of the universe, tell us about them. If you enjoyed this dive into the strange and the marvelous, don't forget to leave a thumbs up and subscribe to the channel so you don't miss any of our future explorations. Activate the little bell, because we have plenty of other fascinating information waiting to be shared. Thank you for being with us on this adventure. Until next time, keep asking questions, keep looking at the world with wonder-filled eyes. See you soon.